I'm a boat builder from the Cotswolds in the UK, and in this video I'm building this huge laminated timber. This forms one of two stringers that run through the middle of a boat called Temptress that I'm currently building. So let's take a look at how I did it. I need to put this down because it is heavy. So the first thing that we need to start out with is a jig in order to form this lamination. So we head down to the CNC machine for this and begin cutting our jig components. Now I've got a new jig design for Temptress and I'll show you the full workings of that eventually, but here we are cutting that first of all. So we've got a load of engravings on these jig components and they're going to help us to transpose lines onto the stringers that we need for things to be cut into them further down the line. This jig is cut from 18mm MDF and that's what we're going to use to form our primary lamination. So the jig fits together with this CNC cut dovetail system, and that allows me to break down the individual components of the jig to parts that will be able to be cut out of a standard 8x4 sheet of MDF or other particle board. And that forms one huge lamination in total. Now the location of these dovetail joints are staggered throughout the two layers that make up this jig, and that allows you to just correct any potential play that might be in that joint by using the piece that spans the dovetail on the first side to just double check and verify your alignment between the two components. Now here I'm doing this upstairs on the mezzanine floor in my workshop, and I've opted to screw this down to the floor just to get some extra rigidity into that jig and prevent any potential deformation of the jig as I pull in the laminates, because there's actually going to be quite a lot of force on this when we start to pull those laminates into shape. And you can see that I've got some polythene laid down under the jig there so that I can work with the epoxy nice and cleanly, and I'm not going to worry about sticking anything to my mezzanine floor. And you can see those engraving marks there that are in this new version of the jig, and I'll get around to explaining exactly what they mean a little bit further on down the line. Okay, so let's talk about some timber species. Now, Temptress was primarily designed to be built from African mahogany. Now, African mahogany is available here in the UK, but not very readily. It's also incredibly expensive and not very easy for me to source for this project. I'm trying to keep costs down where possible. So if you've been following the series, you will have known that I've opted to use utility for this boat instead. And I'm certainly using that for all of the planking, all of the framing and the stem, keel, elements like that. Now utility is a little bit heavier than African mahogany. What we get for all of these timbers is a rating per cubic meter for the weight of the timber, and this is of course an average across the board. There is some variation between it. African mahogany comes in at 530 kilograms per cubic meter and utility comes in at 660 kilograms per cubic meter. So say we had a cubic meters worth of wood in this boat in total, we'd be introducing around about an extra 130 kilograms to the boat by using utility versus using African mahogany. Now I want to try and tip the scales a little bit if I can, put things back into the favour weight wise, and any weight that we can save in the boat in general without compromising its structural integrity is going to be a good thing. So the stringer is a good opportunity to do that. If we can use a different species of timber there, we can save a fair amount of weight. The other area in which I'll do that will be within the hull planking, and we'll talk about that a little bit further down the line. So what have I opted to use? Well, I had a conversation with my timber supplier, Sykes Timber, and they advised me that larch would be a good option. So let's take a look at what that actually is. So more specifically, I'm actually using Siberian larch here. This is a piece of Siberian larch, and you can see immediately how tightly and straightly grained timber this is. Now because this grows in quite a cold climate, you've actually got a very slow growth timber here, and that gives us these really tight grained texture, nice and straight grain as well, which is just perfect for boat building. That is exactly what we want. Siberian larch comes in at 550 kilograms per cubic meter, so that's much lower than the utility that we're using for most of the rest of the boat. And when it comes to doing the internal planking, I'll be using yellow cedar for this, which is even lighter again. That comes in at 495 kilograms per cubic meter, so that should help us to tip the balance back in the favour of where we originally wanted to be weight-wise, if not even slightly better. Now, whilst Siberian larch is technically considered a softwood, it is actually one of the hardest softwoods that are available on the market. And we can gauge that hardness for various different woods using something called the Janka scale. This is a process whereby a 0.444 inch steel ball is pressed into the surface of a species of timber. And the amount of force that is required to push that ball halfway into the timber is measured, and this gives us a gauge for how hard the timber is. Now, let's do some comparisons. The utility that I'm using for most of the boat is an 1180 pound force, so it's quite a hard timber on the overall scale. African mahogany comes in a little bit under that at 1070 pounds of force, so it's a little bit softer than the utility, which we would naturally expect anyway due to the fact that it's a slightly less dense wood and a little bit lighter as well. Now, Siberian larch, although it's technically a softwood, actually measures 1100 pounds on the Janka scale, which means that it actually sits somewhere between African mahogany and utility. So even though it's a softwood, it actually sits in between these two mahoganies that we're kind of weighing up using within this project. Okay, so I've got the larch sorted for the stringers, and I've got 3 different piles. So we've got long lengths and short lengths in each pile, but basically what we've got is incredibly clean stuff. So you can see this full length of this, not a single knot in the whole thing. We've got beautiful tight grain in this. So this is the premium. So you can see that is our perfect candidate. We've got the pile in the middle, and all of these ones are really clean, but they just contain small knots. So relatively small, not going to be an issue. So they're kind of seconds, and then thirds. What we've got over here is anything that contains at least one large knot. So actually a lot of this is still incredibly clean. You can see that that length there is still really nice, but we've just got one large knot in it, which is here. So what that'll probably mean is that that pile just involves me having to just work around those. So I'll probably just cut either side when I do the scarves to join these lengths together. I'll just lose the large knots, and then otherwise the timbers in this pile are all really good. So you can see there, we've still got a really nice clean length. But what we've just got is one large knot here, so that'll be easy just to place the scarf before that and lose that section off the end. So the plan is to kind of mix up a bit of each and split these between the 2 stringers. So I'll probably start by just dividing the really clean pile into 2, and we'll get a nice even mix of grades of timber throughout the 2 stringers. So in order to create the laminations for the stringers, we need to create full lengths of the Siberian larch. Now it comes in very straight and very long lengths, but they're not quite long enough to do this full stringer in one go, and we need to cut some little scarf joints in the ends of them. So first thing I need to do was to create a little jig in order to make that a nice, quick and straightforward process. So let's start making the jig. So we've got an obvious benefit of scarfing the timbers together, which gives an increased strength between where the lengths of timber need to join, but it also means that I've got helpful full lengths to work with when it comes to gluing up the stringer, so I've not got to worry too much about arranging individual pieces. Once all of those are scarfed and glued up together, I then go through the process of sorting these into the order that I actually want them to be within the stringer. And that's also going to allow me to mix up those scarf joints throughout the lamination so that they're in varying positions. So what you'll see me doing here is that the laminates that have a short section at one end of the stringer, I'm alternating the end at which that scarf lies so that we've got variation from one laminate to the next. And although we've got incredible strength within those scarf joints, it means that we haven't got a large amount of joints all within one area of the stringer. So then we start the glue up process. I'm using the West System 105-205 epoxy and hardener mix for this process, and I'm adding some 406 colloidal silica to that. Now this is a slightly different glue up process for this lamination to the process that I normally use. What we're opting for here is a lightly thickened mix. So you can see that it's quite runny in comparison to a fully thickened epoxy. And this is a kind of middle ground between doing the wet out process with unthickened first and then applying a thicken to the joint. In this instance, I'm using a lightly thickened epoxy which gets applied to either face within the laminate layer. And we apply that using a roller, which is much quicker and easier to do on a process like this where you've got a huge amount of laminations. And trust me, this took a long time to glue up and it was quite a stressful and hectic process, but all worked nicely in the end. Okay, so that's the clamps removed from the stringer, and you can see we've got really minimal spring back actually. So spring back is basically where we release the tension that we put into this when we clamp it. That should be held in place as the laminates slip over each other and then the glue cures. So as we release the clamps, we sometimes get a bit of that tension released again, which is what we call spring back. And that's obviously going to be worse in the areas of the sharpest curve, but you can see it here where we've got the sharpest curved section. We've got probably 2 to 3 millimeters, I would say, spring back in there, so that's really minimal, which is nice. That's what we want to see. And we will actually do a stage just to even correct that small spring back. First thing I need to do is just to clean up the faces here. So this is made from 50mm wide stock, and we need to take this down to 44mm.
so that that's the correct thickness. So that's just going to allow me to clean up this glue, get rid of any indifference between the lamination heights. As you can see, there is a small amount there. So we'll get that cleaned up. We'll get it down to 44mm. It's a big piece of timber, isn't it?
Now, you might have noticed that this section of the stringer is separate, and when I glued them up, this didn't actually get bonded to the main part of the stringer. This forms the section back aft from frame 9 back to the transom where the stringer is taller, so we've got an additional reinforcement there. And this is in the area of the boat where the engine's going to sit, so needs to be a bit of extra strength there. But it's not actually parallel, so what this timber needs to do is to taper slightly from 62mm up forward at frame 9 down to 37mm back where it comes through the transom. So the reason for not gluing this up with the rest of that now is that I can then cut that taper, and then it means that we're going to have a nice closed off lamination on the top of the stringer, so we're not going to have that open end grain where the taper cuts through the laminates. It also means that this is a nice handy sized piece that I can actually cheat and size on the sanding machine, which would have been my preferred way to do it versus doing it all by hand upstairs. So first of all, let's get this down to 44mm in the sanding machine, and then we'll mark out the taper. So that is the stringer dimension. You can see we've got the largest section back aft there. We're down to our 44mm finished thickness now. You can see it's looking really nice. And as we come up here, we can see the arrangement of some of our little scarf joints. And you can see how I've just distributed those throughout the layers, so that we haven't got any two certainly next to each other in a laminate, and they're split out and varied. There's one somewhere around the middle here as well. There's one just in there, look. So we're currently slightly oversized. Now I've laminated this up a little bit thicker than it needs to be. This is around about 135mm I think at the moment, and we need to finish at 127. So what that's going to allow me to do is just correct that little touch of spring back that we've got up the far end there, and just get me to bring it down to the final dimension. We're going to do that in the next video, and we'll be putting the stringer back onto the jig here. So the first thing that I'll do is to rescribe that outer profile line. So this new jig is shaped from the outside of the stringer rather than the inside as I did it previously. And this means that we can use this now to shape this to the outside of the boat. So if we take a look at the jig, the main curvature line of the jig is the larger side of the stringer on the outside of the boat. And then this secondary line that we have here is our bevel line. And what we're actually going to do with that is to project it back up onto the stringer. So we take a look at these markings, you can see we've got a plus 50mm mark there. So what we're going to do is put the stringer back up against this face once I've shaped the outer face of it. So we'll shape this edge of the stringer, we'll bring it back down to its final dimension, and I'll use this edge of the jig to do that. Then I'm going to use this line on the jig to project plus 50mm in this direction. That's going to give me my bevel angle and my bevel line, which you can see runs all the way down the full length of the jig. And then we've got our markings here for frames as well. So you can see that this will be frame 8. This gives me the forward and the aft sides of the frame. And then here we've got the depths for the notches in the stringer that are going to receive the frame, and they are on a plus 100mm offset. So they're going to go into the stringer this direction, 100mm. And that gives us the low and the high side of that notch for each frame. So we'll be able to do a lot more of the work for the stringer right here on the jig in the workshop. So we'll get on to that in the next video. I want to say a thank you to everybody for watching these videos, because without the views none of this project would be happening. And I want to say an especially big thank you to all the patrons that are helping me out with some additional financial support towards this project, because I am trying to self-fund this build, and that is going to be a tricky hill to climb, to say the least. So thank you very much guys for the additional help there. Hope you've enjoyed this video, and I'll see you in the next one where we'll get this beast of a timber shaped. Cheers guys.